In this video, we will be solving problems by writing systems of equations. Our objective is to pull important information from a word problem to create and solve a systems of equations. Helpful hint, in order to be able to write a systems of equations from a word problem, one of the great hint would be to actually designate a variable that is based on the information that you're solving for. So example, you could easily use x and y for every time you're going to be writing a system of equations. However, sometimes it might be more helpful to designate a variable or a letter for a variable that represents what you're trying to look for. So for example, an exam is worth 145 points and contains 50 questions. Some of the questions are worth 2 points and some are worth 5 points. How many 2-point questions are there and how many 5-point questions are there? So we're looking for the different types of point questions. So I'm going to designate the letter T to represent a 2-point question, and I am going to designate an F to represent a 5-point question. Do you have to? Absolutely not. But whenever I'm getting an answer, instead of it being x equals 2, but I'm like, wait, what did x represent? Did x represent 2-point or did x represent 5-point? This helps me to be able to understand more. So we will have two equations going on here. One equation is dealing with the number of points. That will be one equation. The next equation is going to be dealing with the number of questions, because we know the number of points has got to total 145, and we know that the number of questions has got to total 50. So how do you write the equations in order to solve for both of these? So I know that the number of 2-point questions plus the number of 5-point questions should equal 50. So I'm going to write that just like I said it. The number of 2-point questions and the number of 5-point questions will represent 50 questions. Now, I also know that every 2-point question is worth 2 points. I know that every 5-point question is worth 5 points. And I know that the total amount of points should equal 145. And that becomes your system of equations in order to be able to solve. Now, at the end of this video, I'm actually going to show you how to solve. I'm going to go back and actually solve every one of these. But since we already talked about a video of actually how to solve substitution elimination, I am going to stop there and continue on, because this video is more pertained on how to actually get to the equations first. Next, we have an example of Kristen who spends $131 on shirts. Fancy shirts cost $28 and plain shirts cost $15. If she bought a total of 7 shirts, how many of each kind did she buy? So I now know that I'm looking for the number of fancy shirts and plain shirts. So I'm going to say F represents the number of fancy shirts, and P is going to represent the number of plain shirts that she buys. Now, there are two things going on. We know the amount in dollars that she spent, and we know the number of shirts that she bought. The amount that she spent was $131. And we also know that she bought 7 shirts. This is actually going to open up of how you write the two equations for this. So let's do the amount of shirts. We know that every fancy shirt costs $28. So I know that should be an F. I was about to write a P. I know that for every fancy shirt, it costs $28 for every one. And we also know that it costs $15 for every plain shirt that she bought. And we know that the total of that amount of money is $131. Now, we also know between the amount of fancy shirts and the number of plain shirts, if you were to add the total number together, you would get 7 shirts. And you now have your systems of equations that you can solve by either substitution or elimination. Next, a class of 195 students went on a field trip. They took 7 vehicles, some cars, some buses. You're looking for the number of cars and the number of buses they took if each car held 5 students and each bus held 45 students. So the first thing I would need to know is, what are we looking for? Well, we are looking for the number of cars and buses. So I'm going to use a C for the number of cars, and I'm going to use a B for the number of buses that it took. Now, I do know that there's 2 equations again going on here. We're looking for the number of students that were taken on this field trip, and we also are looking for we also know that we know the number of vehicles that were taken on this field. We know that 195 students went on this field trip, and we know that there were 7 vehicles. This will actually create our 2 equations. So I'm going to go ahead and start with the vehicles. There are 7 vehicles. We know that the number of cars plus the number of buses should equal 7 vehicles. We also know that you can place 5 people in every car, and we know that you can place 45 people in every bus. And the total number of people is 195. There's our 2 systems of equations. Again, at the end of this video, you may fast forward if you'd like to in order to be able to check your answers to see if you have solved them correctly. Suppose you are starting an office cleaning service. You have spent $315 on equipment. To clean an office, you use $4 of supplies. However, you charge $25 per office. How many offices must you clean to break even? This is a slightly different type of systems of equations because of the way you're going to set this up. You don't have as much information to go on as before. However, you're wanting to know how to break even. So if you look at in the case of the first 2 sentences, deal with how much it cost you to be able to have the cleaning service. It cost you $315 in equipment, and then it cost you $4 per office to be able to clean it. So that's how much it actually is costing you for this service. However, the profit that you gain from this service is that you get to charge $25 per office. Now when I write it out like that, I realize, okay, this is going to be my variable because it says how many offices must you clean. So I'm looking for offices. I'm not going to use O to represent offices because it looks too much like a 0. So in this case, I am going to go back to an X to represent the number of offices. So I know it is going to be 315 plus 4X. I also realize my profit is going to be 25X. The next part is, what do we set it equal to? Well, this wants to know how many offices must you clean to break even. So you want to know how many offices will it take for the amount of cost and the amount of profit to actually equal each other to break even. So you actually will set these 2 equations equal to each other. 315 plus 4X, you want to know when that is actually going to be even with 25X. That is actually the systems of equations that would be set up. In this case, it's actually a 2-step equation, so you're only solving for 1 variable in this problem. Okay, a boat can travel 24 miles in 3 hours when traveling with the current. With, that's actually going to be key in this case. Against the current, it can travel only 16 miles in 4 hours. Find the rate of the current and find the rate of the boat in still water. Hint, distance equals rate times time. And the reason we're using this is because 1, we're given the distance. We're also talking about the rates of the current in the boat, and we're given the different times. So we're going to set up our equations based off this formula. Now, I am going to denote B to represent the rate of the boat, and then I'm going to denote C to represent the rate of the current. Again, you can use X and Y, but it helps me to understand what B and C actually represent. So distance equals rate times time. Well, let's look at the first sentence. The distance is 24 miles. The rate is the fact that a boat is traveling with the current. So you're actually going to add those 2 rates together, the rate of the boat plus the rate of the current, because they are moving together. And then you're multiplying that by time, and the time is 3 hours. Now the second equation, it only travels 16 miles, that is your distance. The rate in this case, it's actually against the current, which means the rate that the boat's going is going in the opposite direction that the current is going. So I'm going to subtract the boat minus the current because they are going against each other. And the amount of time it took was 4 hours. And in this case, you have actually now set up your 2 equations that you can solve to find your different variables. A hint here, go ahead and distribute the 3 and the 4 if you want to, and then you can be able to use elimination in this. Okay, now at this point, I'm going to go back to all these equations and I'm going to go ahead and solve them. So if you were able to work through these problems, you want to check to see if your answers were correct. So the first one is the t plus, this is dealing with the 45 points and the 50 questions. So the way I'm going to solve this is I'm going to multiply the top equation by a -2 in order to eliminate the t's. So I'll get -2t minus 2f equals a -100. In the bottom, I will get 2t plus 5f equals 145. Now, when I add these together, the t's will eliminate each other, leaving you 3f equals 45. So in this case, you would divide by 3, and so f equals 9. What does that mean? That means that there were 9 of the 5-question or 5-point questions. There were 9 5-point questions. Therefore, if I know that the number of questions plus the number of 2-point plus the number of 5-point questions equals 50, I can go ahead and substitute the number 9 into f now that we know what it is. To solve for t, I would subtract 9 and I would get 41. Therefore, that means that there were 41 of the 2-point questions. Next, okay, this is then about the shirts. So the way I would solve this equation is I'm going to multiply the bottom equation by a -15 in order to eliminate the p's. So the top equation does not change, is 28f plus 15p equals 131. And the bottom equation would be -15f minus 15p equals a -105. Now, the p's will eliminate each other whenever I add these two equations together. And so I'll get 13f equals 26. Divide by 13, and I will get 2. What does that represent? That represents that she bought 2 of the fancy shirts. Now, I'm going to plug 2 back into this equilibrium equation. F plus P equals 7. But instead of F, I can substitute in for 2. And so to solve for P, I will subtract 2, and I will get 5. And what does 5 mean? That means she bought 5 plain shirts. Next, okay, we have the field trip. So here are some equations. I'm going to multiply the top equation by a -5 in order to eliminate the C's. So when I do that, I'll get -5c minus 5b equals -35. And then the bottom equation does not change. So when I add these two equations together, the C's will eliminate each other, leaving you 40b equals 160. So therefore, you would divide by 40 and b equals 4. What does that mean? It means that they took 4 buses. Now I'm going to plug 4 back into b. I'm going to take this equation, c plus b equals 7, and I'm going to plug 4 back in. And I would subtract 4, and that means c equals 3. What does that mean? It means that they took 3 cars. In this case, you have only one variable, so in order to solve this equation, I'm just going to draw a line. I'm going to subtract 4x on both sides in order to get them on the same side. So I'll get 315 equals 21x. So I need to divide both sides by 21. And I'll get x equals 15. And what does that 15 mean? It means that she needs to clean 15 offices to break even. Okay, in this case, the first thing we're going to need to do with the equations is we're going to go ahead and distribute the 3 and distribute the 4. There is another way to solve this equation that I'm just going to mention out loud, but I do not want to confuse anyone. Since this 3 is being multiplied by this parentheses, you actually can go ahead and do the opposite by getting rid of it by dividing both sides by 3. Same thing down here. You actually can divide both sides by 4, but maybe I guess the easiest thing to do is go ahead and just distribute the 3. Not necessarily the easy thing. Hang on. Okay, in this case, to solve these equations, there are 2 ways to solve it. I'm going to go ahead and solve it by actually distributing the 3 and the 4 to the parentheses. So I'll get 24 equals 3b plus 3c, and then I'll get 16 equals 4b minus 4c. Now, when you think of the lowest common multiple between eliminating one of the b's or the c's, I'm going to eliminate the c because they already have opposite signs. So the least common multiple between 3 and 4 is 12. So in order for 3 to become a 12, I'm going to multiply the top equation by 4. In order for the 4 to become a 12, I've got to multiply the bottom equation by 3. So when I do that, I will get 96 equals 12b plus 12c. And on the bottom, I'm going to get 48 equals 12b minus 12c. These c's will eliminate when you add these two equations together. You will get 144 equals 24b. And so when you divide by 24, you will get 6. Now, what's that mean? That means the boat had a rate, the boat rate was 6 miles per hour, because we're dealing with miles and we're dealing in hours. So the boat's rate was 6 miles per hour. And now to plug that back in to either equation, I'm going to plug into the top. So 24 equals 3 times b, which we now know is 6. So I'll get 24 equals 18 plus 3c. You can subtract 18 to get 6, and then divide by 3, and c equals 2. What does that mean? It means that the current, like I guess the river current, was 2 miles per hour.